All right, folks. So we are ready to now continue. We started actually last week with this chapter, so we're going to continue stuff that I've already started going through. So ideally, I know you guys had the exam to study for, but at least you managed to maybe take a moment to maybe look at that stuff, so that you have some basis for what we're going to be doing right now. But if not, hey, you get to expose yourself to it, and then that's your first pass on it, and you just need to go back and kind of cover it again and figure it out, and you will, and things will work out. Anyway, so as far as the exam goes, I'm gonna try to grade it by Saturday, so I should have it done hopefully by then. I have another exam to grade that I gave this morning, so I'm gonna grade that one first, and then you'll get an email as you normally do with the curve and your grades uploaded to Moodle and all that. So look out for that. I'm going to work on it. Today's Tuesday, so Wednesday. On Thursday night is when I plan to work on it. So ideally, I'll get it done Thursday night. We'll see, though. No promises, but likely. All right, so Chapter 9 we started talking about last week. Again, we've covered the three market settings that are sort of like, first of all, the extreme ends of the competitive spectrum, the perfectly competitive marketplace, and the other side being the least competitive, the monopoly. And also in Chapter 8, we covered monopolistic competition, which is sort of a hybrid of the two, where, again, you have a lot of competition, but firms also have some market power. And then we moved on to Chapter 9. Chapter 9 deals with the final case, the final model of a market that we consider in econ, which is the oligopoly market, which has a good amount of large firms. It can range anywhere from 2 to maybe, 7 or 8, that basically dominate the market. They have the biggest market shares, and they basically define the market. And their big challenge is that they can, if they somehow figure out, work together and profit from the market the way a monopoly would profit from a market, but it's illegal to do that kind of thing. And so therefore they have to try to figure out the best way to approach the market, given that there are such few players, and they have to take into consideration what their opponents, their competitors, are doing when they're choosing their optimal output, their pricing, etc., because they share the market. So there is the characteristic interdependence in decision making in this market setting, which again is what complicates it, makes it the most complicated market setting, and ultimately makes it the most difficult to analyze, which is why we have models covering 4 different cases in this chapter, Chapter 9, and then we have a whole other chapter, Chapter 10, that deals with another approach to try to solve the problem of these firms, using what's called game theory, which is just a general approach to studying situations where there is interdependence in decision making, in which the people involved are considered players, and there's payoffs that they're playing for, and they can have strategies to try to win the game. And so we'll talk about that when we get to Chapter 10. But the point is that there is enough complexity in this market setting that it requires several different approaches to try to sort of figure out the best way for these firms to operate within them, and ultimately be able to extract some principles that you, as up-and-coming managers potentially, will need if you do wind up in these kind of markets. All right, so we have 4 different models in this chapter. The first one was the Sweezy model, which was covered last time. I'll do a quick review of that one. Then we started on the Cournot oligopoly, which I'll continue today and finish today. And then we will start and maybe even finish the Stackelberg oligopoly today. And that's only going to leave the Bertrand oligopoly. So those are the 4 models that are covered in this chapter: Sweezy oligopoly, Cournot oligopoly, Stackelberg oligopoly, and Bertrand oligopoly. And each model differs with respect to the assumptions that firms make about what their opponents are doing. Because again, there's interdependence in decision making, but there isn't direct communication. And so they need to sort of just try to gather as much information as possible and make the best assumption about what their opponents are going to do given the conditions that they face in the market. All right, so previously, just in general, as far as like what are the conditions for an oligopoly, so just as far as the definition, it refers to a situation where there are relatively few large firms in an industry, roughly 2 to 10, but there's no specific number. If an oligopoly is made up of only 2 firms, it's called a duopoly, and that is the case we generally consider in this class. We keep it simple with two firms. So again, like one of the big characteristics of these markets is that there is interdependence in decision making, and therefore there have to be beliefs about what opponents are going to do, which then need to be taken into consideration when the firms are making their optimal choices. Monopolists easily made their optimal choices by setting marginal revenue equal to marginal cost. Perfectly competitive firms easily made their optimal choices by setting price equal to marginal cost. But for a oligopolist, the case is not as simple because they have to consider their pricing. They have to consider their cost conditions, and they also have to consider the demand in the marketplace. But they also have to consider what their rivals are doing. So that again is what complicates these type of marketplaces for firms, and is why we require several different models to sort of try to best maneuver them. So the first one we covered was the Sweezy oligopoly. The Sweezy model is based on the assumption regarding how other firms will respond to price increases and price cuts. So the industry is characterized by a Sweezy oligopoly if there are few firms in the market serving many consumers, which is the main defining characteristic of an oligopoly. The firms produce differentiated products. Everybody produces something slightly different, much like in a monopolistically competitive market. Each firm believes that rivals will cut prices in response to a price reduction, but will not raise their prices in response to a price increase. So it makes sense that if you are competing with one other competitor in a market and you are lowering your prices, that your competitor would also lower their prices. But if you are going to raise your price, it makes sense that they would not raise their price because then they would be more competitive than you. So that is basically the assumption that's being made in the Sweezy oligopoly. And of course, there are barriers to entry. Barriers to entry are what keep out other firms from being able to compete in these industries. Worst case scenario, you have a monopoly where barriers to entry keep all firms out. But some barriers to entry just require firms to have a certain size to be able to compete, which is what allows them to have a low average cost of production. And so that's what will allow a small amount of large firms to sort of dominate the market. The barriers to entry require firms to be large, and only so many firms are able to generate enough financial capital to get that large. And so that's what ultimately results in this sort of limited competitive setting. All right, so specifically for a Sweezy oligopoly, again, we assume that rivals are going to match price reductions, but they will not match price increases. That means that if the firm is operating at this point here, then the demand that they face, if they lower their price, is going to be more inelastic because again, they're going to lower their prices and their competitors are going to do exactly the same thing. And so as far as elasticity goes, it's going to have no effect. It's going to remain as elastic as it was before. But if they raise their prices and their competitors do not raise their prices, then demand will become more elastic. It'll become more sensitive to price changes. Folks will decrease their quantity demanded from this firm who's raising their price and jump ship and go to the competitor. So that's why you get this kinked demand curve. Again, if they lower their prices, their competitors will lower prices, so you get a relatively inelastic demand. And if you raise your price, your competitors won't raise their prices, so you get the more elastic demand. And so that's where you get this sort of weird demand curve. Now, up till this point, starting here, the demand is again going to be more elastic, and so the marginal revenue curve associated with it is going to be this one here, and then beyond this point, demand becomes more inelastic, so that it's going to have another marginal revenue curve associated with it, which is this one here. And last week when I went through this in steps, like we derived this marginal revenue curve. So if you're confused about why it looks the way it does and you can't quite figure out why it looks the way it does from this diagram, just make sure you go back to the last lecture, and I cover it in very fine detail and I animate the whole thing so it's very clear how we get to this weird sort of marginal revenue curve. Anyway, given the assumption that the firm makes about what their rivals are going to do in response to price changes, this is the marginal revenue curve that they wind up with. What this marginal revenue curve implies is that there's a range over which changes in a firm's cost, therefore its marginal cost, will not have any effect on their profit maximizing level of output. Normally, you might have a situation where marginal cost equals marginal revenue. If, let's say, costs go down, so marginal cost decreases, then you'll be at a point where marginal cost is less than marginal revenue. That means that the firm will want to increase their output. So that's the normal sort of response to that kind of situation. But again, this is a squeezy oligopoly where, again, the firm is making certain assumptions about what their rivals are going to do, which results in this weird marginal revenue curve. And therefore, there's a range over which marginal cost can, let's say marginal cost starts up here. Marginal cost equals marginal revenue at this point. That means this is their profit maximizing level of output. If marginal cost falls anywhere along this range here, all the way down to point E, then at any of those points, the amount of output that maximizes this firm's profit is going to be the same, and therefore they will not change their output at all. So marginal cost drops and they don't change their output, and that's all a result of what they believe their rivals are going to do. And that's an important insight for a firm that operates in this kind of setting, where pricing is the most important sort of dimension in which they compete against their rivals. And so if a firm is not aware and not taking into consideration what their rivals are doing and maybe does increase their output, then they will be making the wrong decision for themselves, and they will be sort of missing the mark as far as maximizing their profit. So it can become tricky. Now, this particular model is good for this very specific type of competitive setting where firms are competing on price. And again, they're making assumptions about what their rivals are going to do with respect to price increases and price decreases. But the question is, what is that price? Like, what is that price that a firm, is at that kind of like changes the nature of demand? And that's one of the criticisms of the model. How does a firm sort of get to that understanding? And ultimately, the insight that can be given to these firms is that, well, it takes practice. Like, you have to be in the market to sort of figure out what that price is. So over time, managers will be able to figure out what that price is and therefore optimize their behavior. But again, it's a very specific type of situation, and this model helps a manager to be able to sort of maneuver this very specific type of oligopoly competitive setting. All right, so then we moved on to the second oligopoly model, which is the Cournot oligopoly. Cournot was this French guy. He came up with this model that basically deals with an oligopoly situation in which the firms are competing on quantity, meaning that they're not competing on price, they're competing on how much each will supply, because there's a certain amount of supply available to be supplied to the market. Generally, you can think of it as like the oil market. There's only a certain amount of oil available. And so the firms have to make output decisions. They have to decide how much are they going to supply of this good that's being supplied. And so they have to take into consideration what their rivals are going to do in order to be able to identify the profit maximizing level of output they should choose in response to what they think their rivals are going to do. So in an industry is characterized as a Cournot oligopoly if there are a few firms in the market and those few firms are serving many consumers, so essentially an oligopoly. The firms produce either differentiated or homogeneous products, so the things that they produce can be slightly different from each other, like in the Sweezy case, or they can be exactly the same thing. So they can be selling the exact same thing or slightly different versions of that thing. Each firm believes that rivals are going to hold their output constant if it changes its output. So that's the main sort of assumption here being made about rivals, meaning that, again, rivals, the amount of output the rivals are going to supply is not going to be affected by the amount that you're going to supply, and vice versa. Like you are basically all making the decision at the same time, and so you can't take into consideration what your rival is going to do. You just have to assume that they're going to behave a certain way, and then that will lead you to the outcome that will maximize your profits given the limited amount of information you have about what everybody's planning on doing. And of course, barriers to entry exist. It's difficult for firms to get into the industry, which again is what sets up the oligopoly setting. So in contrast to the Sweezy model, the Kuno model is relevant for decision making when managers make output decisions instead of pricing decisions and believe that their decisions do not affect the output decisions of rival firms. All right, so the tool that firms use in these markets to sort of figure out how much they should be supplying in these markets is called a reaction function. It's also called the best response function. And essentially, it's what we've been doing. They set marginal revenue equal to marginal cost. But the thing is that marginal revenue is not just dependent on what they do, it's also dependent on what their rivals do. So you're going to have an extra quantity variable in that marginal revenue equation, the quantity for the rival, which will then not allow you to derive an exact number for your profit maximizing quantity. It will allow you, though, to derive a function of your opponent's output that will tell you how you should respond optimally to how much they will supply. So you wind up getting a rule versus just an exact number, but ultimately it's the same thing, because if you can, identify how much your rival is going to produce and you plug that in, then you get to your quantity. So you ultimately can get to one number. So how we look at these reaction functions graphically is we plot maybe firm 2's output on the y-axis and firm 1's output on the x-axis. So this is firm 1's reaction function. Again, it tells it how it can respond optimally to output decisions by its rival in order for it to constantly be maximizing its profit. If firm 2 produces this amount, then firm 1 should produce this amount to maximize its profits. This is firm 2's reaction function, and they meet in the middle, which results in the equilibrium quantities for the Cournot market. So to examine the Cournot equilibrium, suppose firm 1 were to produce, let's say, Q1M. So Q1M represents firm 1 being the only producer in the market. That is the point at which firm 1 is producing this amount and firm 2 is producing 0. It's a duopoly. Firm 2 produces 0. Firm 1 is a monopolist. But let's say firm 2 were to enter the market. The barriers to entry didn't keep them out. They came in. And this is their best response function, their reaction function. In response to firm 1 supplying this monopoly output, firm 2 would supply this amount in order to maximize its profits. In response to this amount, firm 1 would supply this amount to maximize its profits. In response to firm 1 supplying this amount, firm 2 would supply then this amount to maximize its profits. And that process will continue on until they get to the intersection. And the same can be said if either firm started over here. So firm 2 was the sole producer in the market and they were the monopolist, and then firm 1 entered, then firm 1 would react to firm 2 here, supplying this much, and then firm 2 would react to that here, and then it would get them back to the equilibrium. So regardless of where the market starts, ultimately the point at which both firms are doing the best they possibly can, given that they share the market, and they're constantly trying to just optimize their quantity in response to what their rivals are going to do, that is the best result that can happen in the market, which is the Cournot equilibrium for the market. Kuhn equilibrium is a situation where neither firm has an incentive to change its output given the output of the other firm. So it's the natural result of this type of competitive setting where, again, the firms are choosing their quantities and assuming that their rivals are keeping their outputs constant. All right, the next step we took in studying this market model, was to, of course, jump to the math. And so ultimately what it's about, this approach, is to try to solve for the reaction functions and then ultimately try to get to the Kuhn equilibrium outputs. So what you want to do is you want to take the inverse demand function, acknowledge that there's only two firms. We're talking about a duopoly, so there's only two firms. So each one will have a quantity control variable, the quantity variable that each firm will be able to choose. So we separate the quantities into those two, and then this becomes the inverse demand function for the entire market. Then what you do is you take the perspective of a firm, either firm 1 or firm 2. And if you take the perspective of firm 1, let's say you take the perspective of firm 2. So for firm 2, its perspective on the inverse demand of the market is that the rival, firm 1, their output will be constant. And so therefore, the constant for firm 1's perspective on the inverse demand function in the market is going to be A minus BQ1. And so this is the constant, right? It's just like that amount that is the vertical intercept for the demand function. And it's independent of the amount that firm 2 is going to be supplying. So therefore, to get to the marginal revenue of this firm, you just double the slope in absolute value like you normally would. So then you get to this marginal revenue equation from the inverse demand function up here, which again, you see that the constant there is A minus BQ1 because we've taken the perspective of firm 2 and firm 1's output is considered constant. And then we got to the marginal revenue curve for firm 2 by doubling the slope on firm 2's slope coefficient. And then you do the same thing with the other firm to get the other marginal revenue. And then we set each of their marginal revenues equal to each of their marginal costs. And then that gives you two equations that relate the two quantity variables to each other, quantity 1 and quantity 2. And then if you solve for one firm's quantity in terms of the other firm's quantity, you have solved for that firm's reaction function. And then if you want to solve for the Kuhn equilibriums, you take both reaction functions and you solve for two variables with the two reaction functions. Two unknowns, two equations you can solve, and that will get you to the equilibrium quantities. All right, so let's once again go through that demonstration problem I went through at the end of last class to get to these reaction functions and make it a little bit more practical for you so it's not as abstract. So again, suppose the inverse demand function for two Cournot duopolies is given by this equation here. So that's the inverse demand function. And their costs are 0. So we assume that both of their marginal costs to produce are 0, just to keep it simple. So the question is, what is each firm's marginal revenue? Then we're going to solve for what each firm's reaction functions are. And then we're going to solve for the Cournot equilibrium outputs. And then finally, the equilibrium price in the market. All right, so what is each firm's marginal revenue? Well, again, to get the marginal revenue, you take the perspective of a firm. So let's take the perspective of firm 1. So step 1 is to take the perspective of a firm, picking firm 1. That means we take the other firm's output as given. So that means Q2 is going to be part of firm 1's constant. So you're going to have 10 minus Q2, and then it's going to be minus Q1. So that's going to be the inverse demand function from the perspective of firm 1, taking the other firm's output as constant. This is what's called the residual demand. So to get to firm 1's marginal revenue now, you just do what you normally do to get marginal revenue. Just double the slope in absolute value. So essentially, by taking the other firm's output as constant, you are now the only firm in the industry, and therefore you are a monopolist, and that's how you maximize profits, by setting marginal revenue equal to marginal cost, which is why we need to derive the marginal revenue. All right, so here's our marginal revenue. And because, again, both firms are dealing with the same demand, then the marginal revenue for the second firm is going to be symmetric to the one for the first firm. So you just switch the subscripts to get the other firm's marginal revenue equation. All right, now to get the reaction functions, we have to set each of the firm's marginal revenues equal to their marginal cost, which is 0, and then solve for that firm's quantity as a function of the other firm's quantity. So then that will give them a rule that tells them how much they should supply in response to their opponent's supply decision in order to constantly be maximizing their profits. Again, given that there is interdependence in decision making. All right, so we set marginal revenue equal to marginal cost and solve for one firm's output in terms of the other firms. So here is the marginal revenue for firm 1. Set it equal to 0 because, again, we assume marginal costs are 0. And now we just solve for Q1 in terms of Q2 via a little bit of algebra there. So move this to the other side, divide both sides by -2. And that gets us to firm 1's reaction function, which is Q1 equals 5 minus 1/2 of Q2. So firm 1's output equals 5 units minus 1/2 of whatever firm 2 is supplying. As long as firm 1 follows this function, they will constantly be able to maximize their profits in response to what their rival's doing. Because firm 2 has the same marginal costs, 0, then its reaction function will be symmetric. So again, you just switch the subscripts to get to firm 2's reaction function. That is only because they both have the same marginal cost. If they had different marginal costs, you would get different reaction functions. All right, so there's the reaction functions for the firms. What are the Cournot equilibrium outputs? Well, what are going to be the equilibrium outputs that correspond to that point of intersection of the two best response reaction functions? And so you just basically now do some algebra. You have two equations with two unknown variables. So you plug in one into the other, and you solve for one variable, and then you plug that value into the other one to solve for the other one. So to solve for these quantities, again, plug one reaction function into the other and solve for output. So here I'm solving for Q1 by plugging in Q2 equals 5 minus 1/2 Q1 into Q2 into firm 1's reaction function. Doing a little algebra here, 5 minus 1/2 of 5 plus 1/4 Q1 there. So you have 5 minus 5 halves, which is equal to 5 halves. And then subtract 1/4 Q1 from both sides to get 3/4 Q1 on the left equals 5 halves. Multiply both sides by 4/3. That gets us to firm 1's optimal output, given that they share the market with this other firm and they're competing and they are choosing quantities, to be 10/3. So this is the amount that they will choose in order to maximize their profits, again, given the interdependence. Given the fact that both firms have the same reaction function, you're going to get a symmetric equilibrium Cournot quantity as well. So firm 2, if we plug in firm 2's output, if we plug in firm 1's optimal output into firm 2's reaction function, then we will get, again, the same amount. So plugging in 5 minus 1/2 times 10/3, doing a little bit of math there, will get us back to, well, it's 5 minus 5/3. 5 is 15/3, so that's going to equal 10/3. So firm 2's optimal output will equal 10/3 as well. So again, these quantities are the quantities that correspond to that point where the two reaction functions intersected in the graphs that we looked at a second ago. And what is the equilibrium price? Well, we have the two quantities of the two firms that they're going to choose, so plugging those into our inverse demand function will get us into the price that they will both charge in the market. In this case, it's going to be equal to $3.33. So that will be the market price in this market. Again, the interdependence complicates it, but again, they both share the market, so they share a downward sloping demand curve. So together, they work as a monopolist essentially. So the approach to maximize profits is the same, but they have to take into consideration what their rival's doing, which is what their reaction functions are. So if you understand everything we've done so far, this is just taking it one step further. So it's not like a completely different thing. If you just kind of go on the knowledge that you've already learned and just kind of build on it, adding this extra complication to it, then it should be the next logical step versus like a completely new and different thing. All right. So in the Kuhn oligopoly industry, output is lower than the socially efficient level. Again, like in a monopoly, you're going to get that deadweight loss. You're going to get those mutually beneficial transactions that don't occur because, you know, the firms are able to use their market power to charge prices above marginal cost and limit the amount that's sold in the market in comparison to what would prevail in a perfectly competitive outcome. The amount by which price exceeds marginal cost depends on the number of firms in the industry. The less the amount of firms in the industry, the more price will exceed marginal cost. It also depends on the degree of product differentiation. If there is more variety in what's being sold by the different firms, there's going to be more market power. So again, price will tend to be larger than marginal cost when there's a lot of different versions of the same thing being sold versus you're getting a homogeneous, similar, or maybe ultimately the exact same product being sold, in which case the price will be closer to marginal cost in those cases. When the number of firms is arbitrarily large, if we get beyond that 10 firm threshold, 10, 12, 14, however many, the equilibrium price in a homogeneous product Cournot oligopoly, so in a Cournot oligopoly where the product is the same, it will be arbitrarily close to marginal cost. So as the number of firms get big, then again, price will start to get closer and closer to marginal cost, and industry output will approximate that under perfect competition. So as more firms compete in these industries, as there's more competition, it's always going to be heading towards the perfect competition outcome. But again, the worst case scenario is when you have just like 2 firms, 3 firms, 4 firms, limited number of firms, and essentially you will get a result very similar to a monopoly outcome, and the market will hurt as a result of it. Prices will be high. But as far as managers go, that's a good thing because profits will be higher. All right, now we're going to examine the profits that these firms can make and the incentive that these firms make, the incentive these firms have to cheat on each other and not operate at that Cournot equilibrium, but operate at a better equilibrium that will actually increase their profits at the cost of their rivals. So with a basic understanding of Cournot oligopoly, we examine how to graphically determine the firm's profits. We use what are called ISO profit curves. ISO, same profit curve. So along each ISO profit curve, the amount supplied is going to result in the same amount of profit. So the ISO profit curve is the basic tool used to summarize the profits of a firm in Cournot oligopoly, which defines the combinations of output that of all firms that yield a given firm the same level of profit. So you've got this ISO profit curve here. So for firm 1, if it were to supply this amount or this amount or this amount or this amount, all of those amounts correspond to the same level of profits. So the figure represents a reaction function for firm 1. So here's firm 1's reaction function, along with 3 of the firm's ISO profit curves. 4 aspects of the ISO profit curves are important to understand. 1, every point on a given ISO profit curve yields firm 1 the same level of profits, as I mentioned already. 2, ISO profit curves that lie closer to firm 1's monopoly output correspond to higher profits for that firm. So as the ISO profit curve gets closer and closer to that monopoly output for the one firm in which firm 2 is supplying 0, then each ISO profit curve corresponds to higher levels of profit. So pi 1c represents higher levels of profits along it than pi 1a. The ISO profit curve for firm 1, each one reach their peaks where they intersect firm 1's reaction function. So again, if like let's say firm 1 is supplying this amount, that means that firm 2 is supplying this amount. So firm 1 supplying this amount, firm 2 supplying this amount. As we move closer to the reaction function, firm 1 supplies more, and firm 2 supplies more as well. And so when they're both supplying more, you're going to get to the top of the isoprofit curve, which is going to be on the best response function, on the reaction function. So that's why we see these isoprofit curves sort of increasing, getting to the reaction function, then decreasing after that. But again, the profits aren't actually decreasing because along the isoprofit curve, the profits are the same for each output level. You'll understand why this is all important in a second. The isoprofit curves do not intersect one another, again, because along each isoprofit curve, the level of profits are the same. All right, so recall that one assumption of the Cournot oligopoly is that each firm takes as given the output decisions of rival firms and simply chooses its output to maximize profits given other firms' output. So this is illustrated in the figure where we assume that firm 2's output is given by, let's say, Q2 star. So firm 2 has decided to supply this much output. Since firm 1 believes that firm 2 will produce this output regardless of what firm 1 does, again, it assumes that its rival's output is constant. It's going to choose its output level to maximize profits when firm 2 chooses Q2 star. So one possibility is for it to supply, obviously, this amount at point A, which corresponds to Q1A in response to Q2 star. But obviously, it can do better. It can increase its profits by supplying a little bit more, and that will get it on this lower isoprofit curve, which corresponds to higher profits, which we know because it's closer to the firm 1's monopoly output. But it can actually do better than that. Profits can be further increased if, in reaction to Q2 star, firm 1 were to supply Q1C, which is the amount that corresponds to its reaction function, which is what tells it that it is maximizing its profits. So this very clearly establishes the fact that the reaction function does provide the firm the best response to their opponent's output decision that will maximize its profits. In this case, in response to firm 2 supplying Q2 star, this amount gets firm 1 on the best isoprofit curve, which is this one here. It would not be profitable for firm 1 to increase output beyond C because going past point C will get the firm on a higher isoprofit curve, which corresponds to lower profits. So point D, as you see, corresponds to lower profits once again. All right, so the profit maximizing output for firm 1 is Q1C when firm 2 produces Q2 star units of output. So we've just, again, reinforced what the reaction function represents. But this whole thing was about you understanding what an isoprofit curve and how it works in order to gain the insights that we're about to demonstrate in the next slide. So to maximize profits, firm 1 pushes its isoprofit curve as far down as possible, this one here, as close as possible to the monopoly point until it is just tangential, just touching the given output of firm 2, and that happens, of course, on the best response function. That's the point that corresponds to the best response function. And of course, things work exactly the same way on the other side. If we were taking the perspective of firm 2, and this is its best response function, then these are the isoprofit curves that correspond to it. The closer the isoprofit curve is to firm 2's monopoly output, the higher the level of profit. As the isoprofit curves get close to the monopoly point, the level of profits for firm 2 increases, as I already said. All right, so we can use the isoprofit curves to illustrate the profits of each firm in a Cournot equilibrium. So this is, again, the Cournot equilibrium where you have the two reaction functions intersecting, the two levels of output that maximize both of their profits, given that they have to take into consideration what their rivals are doing. They're choosing output, and they're assuming their rival's output is constant. So this is a Cournot equilibrium, and these are the isoprofit curves. This is the one corresponding to that Cournot equilibrium for firm 2, and this is the one corresponding to the Cournot equilibrium for firm 1. So this is the best they can do in terms of profits given what they face here. All right, so one thing we will look at here first is the changes in marginal costs, as we talked about in the Sweezy oligopoly case. When marginal cost changes over a certain range, that's not going to affect output. In a Cournot oligopoly, the effect of a change in marginal cost is very different than in a Sweezy oligopoly. Suppose the firms initially are at equilibrium at point E, where firm 1 produces Q1 star and firm 2 produces Q2 star. Suppose further that firm 2's marginal cost declines. So firm 2's marginal cost declines. So that means that at any given level of firm 1's output, firm 2 can now supply more because its costs have now gone down. So this means that for firm 2, marginal revenue exceeds the lower marginal cost, and it is optimal to produce more output for any given level of Q1. So at the point that they were at, marginal revenue was equal to marginal cost for each firm, but marginal cost declined for firm 2. So marginal revenue was actually greater than marginal cost at that original point, which means that the firm will increase its output. So graphically, this shifts the reaction function for firm 2 up, which then gets the Cournot equilibrium to a new level, given the way that we talked about earlier, how we get to an equilibrium. We were originally here. Firm 2's reaction function moved here. So in response to firm 1 supplying this much, firm 2 will supply this much, and then firm 1 will supply this much, firm 2 will supply this much, and that will get them to the new Cournot equilibrium. So again, this graphical shift leads to a reduction in firm 2's marginal cost. The reduction in firm 2's marginal cost leads to an increase in firm 2's output. So firm 2 increased its output from Q2 star to Q2 double star. And that also leads to a decline in firm 1's optimal output from Q1 star to Q1 double star. Again, they share the market. They share that downward sloping demand curve. And so if one of the firm's marginal costs went down and they are increasing their supply, then that means the other firm needs to not supply as much as they were supplying before, because if they do that, then that means the price would fall and both of them would be hurt. So they need to respond to what the other one is doing in order to maintain their profits. So firm 2, in this case, given that their marginal cost has decreased, enjoys a larger market share due to its improved cost situation. All right, so the reason for the difference between the preceding analysis and the analysis of Sweezy oligopoly is wholly centered on the difference in the way that a firm perceives how other firms will respond to changes in their decisions. These differences lead to differences in the way that a manager should optimally respond to a reduction in a firm's marginal cost. If the manager believes that other firms will follow price reductions but not price increases, the Sweezy model applies. In this instance, we learned that it may be optimal to continue to produce the same level of output if marginal cost declines, as I mentioned. If the manager believes other firms will maintain their existing output level if the firm expands output because marginal costs decrease, then the Cournot model will apply. In this case, it's optimal to expand output if marginal cost declines. The most important ingredient in making managerial decisions in markets characterized by interdependence is obtaining an accurate grasp of how other firms in the market will respond to manager decisions. All right, now let's again throw up our isoprofit curves and then talk about this very interesting sort of situation that the firms are in, which is that they are competing against each other, but they could be working together like a monopolist and benefiting together from the market like a monopolist would. When they do that, they are colluding with each other. So that's where the collusion term comes in there. So whenever a market is dominated by a few firms, firms can benefit at the expense of consumers by agreeing to restrict output, or equivalently to charge higher prices. So they can get together and say, hey, you know, we can charge this price that a monopolist would charge, but you have to agree to only supply this certain amount. And so that's what they ultimately would like to be able to do. But again, that's illegal to do so. And because it's illegal to do so, even if they manage to get behind closed doors and make those kind of agreements, there's no legally binding way to enforce the agreement, right? Because it's illegal. And so it's really easy for the firms to cheat on each other. All right, so such an act, when they try to get together and kind of rig the market, is known as collusion. In the next chapter, we will devote considerable attention to collusion via game theory. Here, it's useful to use the model of Kuno oligopoly to show why such an incentive for collusion exists, and also why there's an incentive to cheat on those agreements. All right, so here is, again, firm 2's ISO profit curve and firm 1's ISO profit curve corresponding to the Kuno equilibrium. This sort of area right here, this blue area, this lens, contains output levels for the two firms that will yield higher profits for both firms than they earn in a Kuno equilibrium. So again, inside of this area here, if they were to sort of figure out that they could be making more money by each one supplying less, because here firm 1 supplying this much, firm 2 supplying this much, to be in here, firm 1 would need to lower its quantity, and so would firm 2. But by doing so, it would get them on these higher ISO profit curves. They're higher in terms of their profits, but obviously lower in terms of their positioning on the graphs. But again, the closer the ISO profit curve is to the monopolist quantity for the corresponding firm, the higher the profits. So again, they could be both supplying this much and both of them be earning more money. They have that incentive to be able to do that. So if each firm agrees to restrict output, the firms could charge higher prices and earn higher profits. If firm 1's profits would be firm 1's profits would be highest at Q1M, obviously, if firm 1 were to dominate the market, where it is a monopolist, and firm 2's profits would be highest at Q2M, where it is a monopolist. If each firm agreed to produce an output that in total equaled the monopoly output, so if the sum of the two equaled the monopoly output, so that would land both of the firms somewhere on this line, which would represent sort of a weighted average of the two that would correspond to the total this amount or this amount. So if they were to somehow figure out that an agreement where maybe firm 2 supplies this much and firm 1 supplies this much, or maybe firm 2 supplies this much and firm 1 supplies this much, if they do that, then they would be together behaving like a monopolist and benefiting from the market the way a monopolist does. So any combination of outputs along that line would maximize total industry profits. Suppose firms agreed to collude. They agreed to work together. Yes, we are going to work together. We are going to limit our outputs, and collectively, we will dominate the market the way a monopolist does. So we would get that collusive outcome there, that point there on that line, on these higher ISO profit curves that, again, would benefit both firms. They would both do better than if they just kind of didn't collude and just base their decisions off what they think their opponents are going to do. So there's certainly an incentive there for the firms to collude, for them to get together and work together. They can benefit from doing so. Now, it's also important to note that there is an incentive to cheat on these agreements. Again, they get together, they decide to do this, but it's illegal to do that in the US and in most Western countries, and so the only way they could do it is illegally, and illegal agreements are not legally binding. So, let's say they get together, hey, yeah, Joe and Bob, they get together and they say, yeah, we're going to collude. We're both going to supply this much. We're going to cut our supply. That means we get to raise the price. It means we get to raise our profits. But once they leave, firm 1 decides, you know what? I'm going to actually supply this much, which is the amount that they would supply in a cheating situation where they have agreed to supply this much. But firm 1 knows that if it supplies more, then basically it will be able to earn higher profits. It will move both firms along the demand curve. So increasing the supply will lower the price, but lowering the price will wind up making this firm's output way more competitive than this one, because obviously it'll be selling at a lower price. And therefore, the overall increase in profits will outweigh the losses in the drop in prices, whereas this firm will wind up getting hurt severely by it because they are still charging the higher price and supplying that quantity that they agreed upon in their collusive agreement. So this suggests that a firm can gain by inducing another firm to restrict output and then expand its own output to earn higher profits at the expense of its collusive partners. So this is one way of highlighting the fact that that is very clearly something that these firms want to do and are able to do, and it very much highlights the complexity of this market setting, where again, there is interdependence in decision making, there is an incentive for them to work together, and they cannot form legally binding agreements, so there is an incentive for them to cheat as well, and that just creates for them a very particular type of situation, which again, even though we highlight the nature of it here, we have other approaches to try to solve this problem that the firms wind up in. It's called the prisoner's dilemma. You were introduced to it in your introductory micro courses. We'll go over it again in the next chapter when we talk about game theory, and we'll look at different ways of thinking about this type of situation, and it'll help us to sort of get to different sort of outcomes for these firms that don't necessarily require them to explicitly make agreements. But just the threat of the cheat is enough to kind of keep them at bay, as long as the benefits of not cheating outweigh the costs. So it's all about comparing costs and benefits, which we'll talk about in very fine detail in the next chapter. So anyway, because the firms know that the incentive exists for cheating, it's often difficult for them to reach a collusive agreement in the first place. So just put aside the fact that it's illegal for them to do this, the fact that they have, a very legitimate fear that their rivals are going to cheat on them generally stops them from even forming these agreements to begin with, which keeps them at the Cournot equilibrium output. Yeah.
So there's no way that they can get to that area, that lens area, unless they agree.
Right, unless they agree.
There's no
because the best response function tells you the best you can do without being able to interact with your rival. Right.
Because this is the
right, exactly. The only way they could agree not to be there is to actually have a discussion about it and say, well, let's just get over here. It's illegal. Yeah, you can't do it. Yeah, so there's so recently in the film industry, the they're trying to figure out, because theaters have like this, they basically have like, so back in 1948, the government broke up the film industry. They used to produce, distribute, and exhibit. They used to own the theaters as well. They were deemed to be a monopoly, and they were broken up by the government. And now, so the theaters are independent, and they have contracts with movie studios, basically saying you have to have movies out for a certain amount of time, and you cannot release them at home, first before a certain amount of time has passed. But now they're trying to figure out how to sort of come up with new agreements, and so they've come up with these profit-sharing agreements where the content, the films, can be released early, and they're coming up with these new systems where people at home, like if they buy a certain box, they can watch brand new movies that are released in theaters, but they have to pay like $50. So you have to pay like $50 or something to watch a movie. And the thing is, like, each studio has to make a deal with each exhibitor, which each theater chain individually, to figure out what that price is going to be, because of the laws that stop them from working together to set prices. So that's a situation where it's kind of working in the opposite direction. It's kind of halting progress, because if the firms were able to just kind of all get together and talk about it, well, let's all decide on the one price of what we should charge for these movies, then it would just be a lot easier and the market would operate a lot easier. But it's good that we have these agreements. Firms should not be able to get together and just make agreements about pricing, because then we would all be screwed. And every market we would operate in would operate like a monopoly, essentially, and all prices would be as high as they possibly can be. So that ultimately it is a good thing. But again, it's all about the complexity of competition and how interdependence just complicates the whole thing. And that's why we need all these types of models to try think through the problem as much as possible. But again, these problems are complicated because a lot of people are involved, a lot of money's involved, and that's always going to create, maybe too much complexity for us to really perfectly solve the problem, right? But tools like this kind of help us to maneuver them the best way possible. All right. So again, firm 1 can cheat and make more money. The problem is amplified by the fact that firm 2 earns less at that point than it would have earned at the Kuno equilibrium. So if firm 2 were to cheat, then this would be firm 1's ISO profit curve, which corresponds to a lower level of profit than this one here, the Kuno profit curve. So therefore, again, that just highlights the fact that one firm will be hurt if the other one takes advantage of the fact that they can cheat. All right, let's move on to the third oligopoly setting, and then we'll call it a day at 9:45 because I got to finish this section. So the Stackelberg oligopoly. So the Stackelberg oligopoly is a situation in which it's very similar to the Kuno oligopoly setting, but the only difference is that one firm gets to make their output decision first. So there's a leader. They get to decide how much they want to supply, and then their rivals have to respond to that and then set their output decisions, which is different than the Kuno oligopoly, where each firm makes their output decision at the same time. So they all have to decide at the same time how much they're going to supply, and therefore the best response function is the best way for them to figure out how much they should supply. So the Stackelberg oligopoly just has that one extra step. But so even though the Stackelberg leader will have a different approach to how they choose their profit maximizing level of output, the rivals will behave like Kuno participants in the Kuno oligopoly. So everything we just did as far as solving for Kuno reaction functions and Kuno quantities is going to be the same for the rivals to the leader in the Stackelberg oligopoly. The only difference in this setting will be what the leader is going to do and how they go about maximizing their profits. So until this point, we've analyzed oligopoly situations that are symmetric, in that firm 2 is the mirror image of firm 1. In a Stackelberg oligopoly, firms differ with respect to when they make decisions. Specifically, one firm, the leader, is assumed to make an output decision before the other firms. Given knowledge of the leader's output, all other firms, the followers, take as given the leader's output and choose outputs that maximize profits. So in a Stackelberg oligopoly, each follower behaves just like a Kuno oligopolist. The leader does not take the follower's output as given, though. The leader chooses an output that maximizes profits given that the leader knows that each follower will react to this output decision according to a Kuno reaction function. So the leader has to take into consideration the Kuno reaction that the followers are going to take in response to what the leader does. An industry is characterized as a Stackelberg oligopoly if there are a few firms serving many consumers. Of course, it is an oligopoly. The firms produce either differentiated or homogeneous products, so it can be either. There's a single firm, the leader, that chooses an output before all other firms choose their outputs. And finally, all other firms, the followers, take as given the output of the leader and choose outputs that maximize profits given the leader's output. And of course, there are barriers to entry. So to illustrate how a Stackelberg oligopoly works, let's consider a situation where there are only two firms. There's going to be a leader and a follower. Firm 1 is the leader and thus has a first mover advantage. The first mover advantage changes the outcome of the game. So again, I'm starting to talk about this as a game because ultimately it is a game, really. And that's why it's good to use what's called game theory to analyze these situations, which is what we'll do in the next chapter. Nonetheless, even though we're not looking at it as an actual literal game here, there is a mover that gets to move first, that gets to benefit from the market first. And then firm 2 is the follower, and firm 2 maximizes profits given the output produced by the leader. The follower's profit maximizing level of output is determined by its reaction function. All right, so this is firm two's reaction function here. So the leader knows the follower will react according to that reaction function. The leader knows that the firm two will take the Cournot approach, and they will have a Cournot reaction function. So the leader must choose the level of output that's going to maximize its profits, given that it knows the follower will react to whatever the leader does in a Cournot fashion. Since it knows the follower will produce along R2, which is firm two's reaction function, the leader simply chooses the point on the follower's reaction function that corresponds to the highest level of output for it. So it chooses the output along firm two's reaction function that's going to give it the highest level of profits. Because the leader's profits increase as the ISO profit curve gets closer to the monopoly output, the resulting choice by the leader will be, in this case, at point S. So point S is the best the leader can do. And again, it corresponds to the highest level of profits that it can earn, given that, again, it knows that firm two is going to react in a Cournot fashion. So this ISO profit curve, denoted pi 1s, yields the highest profits consistent with the follower's reaction function. Again, it is tangent to firm two's reaction function, thus the leader produces Q1s units of output. The follower observes this output, is able to see what the leader does because the leader goes first, and then produces, of course, Q2s, which is its best response to firm one producing Q1s. And that will maximize its profits. So notice that the leader's profits are higher than they would be in a Cournot equilibrium, where firm one would be making these profits here. So obviously in this situation, the leader, because they have a first mover advantage, gives them an overall advantage in the market, raising their profits, and because there's interdependence, it lowers the profits of the rivals. By getting to move first, the leader earns higher profits than would otherwise be the case. All right, the algebraic solution for a Stackelberg oligopoly can also be obtained, provided that firms have information about market demand and costs. In particular, recall that the firm's decision is identical to that of the follower's decision is identical to that of a Cournot model. So with a homogeneous product, linear demand, and constant marginal costs, the output of the follower is given by your standard reaction function, which we can solve for doing the exact same thing we did earlier to solve for both the Cournot reaction functions. The leader in the Stackelberg oligopoly takes into account this reaction function when it chooses Q1. So it chooses Q1 first, and it takes into account the fact that firm 2 is going to use this reaction function to respond to it to choose its output. So this demonstration problem will highlight how it is that firm 1 will choose its output, knowing what it knows about what firm 2 is going to do. So suppose the inverse demand function for two firms in a homogeneous product Stackelberg oligopoly is given by this expression here. That is the inverse demand function. Here's quantity divided into the control variables for both the leader, firm 1, and the follower, firm 2. The cost functions for both firms are these. Marginal costs are constant for each, equal to 2. Firm 1 is the leader, firm 2 is the follower. What is firm 2's reaction function? So that's the first thing you need to solve for, is firm 2's reaction function, because firm 1 is going to take into account the fact that firm 2 is going to react in a Cournot fashion. So firm 1 needs firm 2's reaction function. Then it will plug that into the inverse demand function to give it the perspective it needs on the market in order for it to be able to maximize its profits, given what it knows about what its rival is going to do. So we're going to solve for firm 1's output. Once we solve for firm 2's reaction function, then we're going to solve for firm 2's output by plugging in firm 1's output into firm 2's reaction function. And then we're going to solve for the market price once we have both of their outputs. And then we're going to go home. All right, so what is firm 2's reaction function? Well, it's how you solve for a Cournot reaction function. You take the perspective of firm 2, right? So from firm 2's perspective, the demand is 50 minus Q1. That's the constant, plus Q2 minus Q2. So then you just put a 2 in front of the Q2, and that gets you to the marginal revenue function for firm 2. So 50 minus Q1, again, it took firm 1's output as constant, and then we just had the residual demand. We doubled the slope on Q2 to get to the marginal revenue for firm 2. So this firm 2's marginal revenue function, set that equal to its marginal cost of $2, and then solve for its output Q2 as a function of Q1 to get to its Cournot best response function, the reaction function. So again, just subtracting this from both sides, dividing both sides by 2, gets us to firm 2's Cournot reaction function to be 24 minus 1/2 Q1. There it is. All right, firm 1's output. So firm 1, again, is the first mover. So they are deciding how much they're going to supply, knowing that firm 2 is going to react in this way. So what they need to do is incorporate this into their perspective on the demand. So that's what they do. So here is the demand function. And now firm 1 is taking into account the fact that firm 2 will set Q2 by this reaction function. So we plug in Q2 into the inverse demand function for Q2. And so we get this equation here, which we can simplify. 50 minus 24 equals 26. And then you have minus Q1. And then you have plus 0.5 Q1, which is equal to then 0.5 Q1. So this is the demand function for the leader now, who can now make its first move, basically working as a monopolist, having incorporated the fact that it knows that it is sharing the market with its rival who's going to react in a Cournot fashion. So now just getting the marginal revenue for firm 1, setting it equal to firm 1's marginal cost, which is 2. We can solve for the leader's output as you would for a monopoly, and it will choose to supply 24 units of output. Again, having incorporated the fact that it knows that firm 2 will act as a Cournot. So that's 24. Firm 2's output is the reaction to that. So we plug that into firm 2's reaction function. And that gets us to 12. And then the market price, we plug in both the leader and the follower's output into the inverse demand function to get us to $14. And in general, price will exceed marginal cost in a Stackelberg oligopoly, meaning industry output is, again, below the socially efficient level. But it actually winds up being more efficient than a Cournot oligopoly, all due to the fact that a Stackelberg, that a leader, that somebody gets to go first in choosing their output decision. The leader winds up doing better than the Cournots, but overall the market winds up having a better result, being more efficient than a Cournot oligopoly. Anyway, that's the third of the oligopoly models, and we have one more to go, and then we're going to jump onto the game theory. So make sure you spend some time thinking about this stuff. I know you guys have been through a lot studying for the exams and all that, but the class isn't over yet. So we have definitely more stuff to cover. So make sure you guys are not falling behind on this stuff, because as you can see, it can get complicated unless you're really in tune with it. If you're really in tune with it, it makes a lot of sense, but you really have to spend the right amount of time to just really understand it. I understand if you don't do that this weekend, but do it quickly before we get too far ahead and then you do not have an opportunity to do so. Anyway, good job on A, getting through the exam, and B, staying through the lecture. I really do appreciate you guys, all of you staying. I really do. Thank you for that. And I hope you guys have a great night. And I will see you next week. Yeah. Yeah. That is something that is already happening. Yeah. Yeah. You have to look it up because it's not very common. So you have to look up who's doing it. But it's very rare right now. But it's definitely moving towards it happening more. Again, each company has to make agreements with the theaters because they have to share the profits of what they collect in these home markets. Anyway, have a good night, folks. I'll see you next week. Take care.